Hello and welcome guys. So in this video I am going to make a face eye smile detection system. So for this I am going to use a OpenCV library of Python. So let's get started. So before getting started, let's try to understand how we can do this. So first of all, our task is to read image from webcam, that is real-time image, and we will try to detect the face from that image and eye from that image, and if there is smile in that real-time image on the face, then we have to detect smile also. So how we can detect it? If there is face in that image, then we are going to plot a box, a rectangular box, which will show that it's a face. Part of eye is also marked with different color of box, rectangular box, showing that it's a eye. And if there is smile on the face, then we are going to mark another box which is showing smile. Okay, so something like that we have to do. So let's get started. So first of all, I am going to use here OpenCV library. So you have to install that OpenCV library. So let's go to Google. So let's search for install OpenCV Python. Okay, yeah, so let's go to this PyPy. Yeah, and from here just type this command on your command prompt or terminal. Okay, so let's copy this from here. So for I'm using Anaconda, so I have so I'm going to install it from here. And so let's type this pip install opencv-python and let's press enter. So I have already installed this. So using this command, you will be able to install OpenCV. Okay. So our library is installed. So what's next? So let's create one folder for this project. Let's name this face eye smile. Okay. So let's add one more file. Yeah, it's you can main.py. Yeah, so this is our Python file. Yeah, so let's drag this to a spider. Yeah, so this is our main.py file, and we are going to implement and we are going to do all the implementation in this file. Okay, so our file is ready, but before getting started we have to use some XML file because we are going to detect feature of face, eye and smile. So for this I am going to use a CV2 hair cascade feature. So what is hair cascade? I will explain you. First of all, let's search here hair cascade XML. Okay, so let's go to this link. Yeah, this is github.com OpenCV. Yeah, this link, and here there is hair cascade eye feature. These are XML file which will help us to recognize the feature of face, eye and smile. Okay, so what we have to do, we have to use this hair cascade underscore eye.xml file, and also we have to use this one, this one, hair cascade frontal face underscore default.xml. Yeah, this will help to identify face, and this hair cascade eye feature XML file will help us to identify eye. Okay, and there are many feature: full body, left eye, lower body. Yeah, these are the feature, and this is third feature which we are going to use. This is hair cascade underscore smile dot xml. So these are three feature which we are going to use. So let's create one text file directly I, and let's create one more file as text file as face. Yeah, one more file as smile. Okay, and what you have to do, just click on hair cascade eye feature and copy the raw content from here and just go here. This is our eye. So let's open this from notepad. Okay, and let's copy this and save this with XML. Okay, so you have to create XML. Yeah, so this is our XML is prepared. So like that we have to use for, so our eye is done, and what's next is frontal face, because if we are going to clone everything then it is very long file, and we have you can also clone this. Yeah, you can also clone this from here, but I'm not going to do this. So let's copy this raw content of this face feature, and let's do here, and just XML, do XML. Okay, and now we need smile. Okay, so smile this feature, and just copy the raw content from here and go here and paste here. Okay, so it's done, and let's change this extension to XML. So it's done. Okay, so we got our smile feature, face feature, and eye feature. Okay, so now we are ready for implementation. So what's next? So first of all, let's comment out with importing libraries. So first of all, importing library. So we have to import, we are going to use only one library, that is CV2. OpenCV is CV2. Okay, so we are going to use CV2. Okay, so what's next? CV2 is imported, and let's comment out with loading cascades. What is cascade? Yeah, I have to explain. So these cascades are basically a feature. Okay, so these cascades are feature which we are going to use here. Okay, so this is our cascade. As you see here, this is our hair cascade. So what is this cascade? This cascade are the feature of OpenCV library. Okay, so we are going to use this this XML file to detect the face feature from that real-time image using CV2, and using this one, and the same for to determine eye, same to determine frontal face, smile. So we are going to use this three feature of CV2 to detect the face, eye, and smile. So that's why we are going to use this hair cascade file. Okay, so first of all we have to load this hair cascade. Okay, so first of all let's create one variable face cascade. Okay, so it is face cascade. So what it will do, it will take CV2 dot, because we are going to read that, yeah, that XML file. Yeah, so this XML file we have to read. Okay, so what I'm going to do here, so I'm going to use here CV2 dot cascade. Yeah, I'm going to use a cascade classifier class of CV2, and I'm going to pass here this one, this face.xml I'm going to pass. Okay, so let's pass here face.xml. Same I'm going to use for eye cascade, eye underscore cascade. Yeah, eye cascade CV2 dot cascade classifier, and type here eye.xml. Okay, same for smile cascade, and pass here CV2 dot cascade classifier, and type here smile dot xml. So we got our face cascade, eye cascade, and smile cascade. Okay, so we got our face cascade, eye cascade, and smile cascade. What's next? We have to make a function. Okay, make a function which will detect face, eye, and smile. Okay, so this function will do everything. Okay, make a function, make a recognition function. Yeah, This one is good. The recognition function. Okay, so in this function, in this detect function, I am going to do everything. Okay, so what I have done, I have readed this face XML file and stored in this face cascade. This is feature of face. Okay, this is a functionality which we are going to use to detect the face, and this is the functionality to detect eye, and this is the functionality to detect smile. Okay, not so complicated. Okay, so these are the functionality to detect the to detect face, eye and smile. Okay, so this function will take image in two form. First one is gray image. Make sure one more point to be noted, that CV2 library always process image in the form of black and white. Okay, it will not process color image. Okay, so CV2 always process image, always perform, always all the detection, all the recognition, all face recognition, eye recognition, smile recognition, everything is going to be done on black and white image, not on colored image. Okay, so first of all, let's pass here this gray. This gray is a variable which contain black and white image. Okay, and second one is color image, because what we have to do, let's pass here gray image and color image. Okay, what we are going to do here, this gray image is used to detect face, detect smile, and this color image is our original image. So after detecting smile and everything, we are going to mark it on this color image and display it as a output, because we want our output in the form of color image, that is live image, which is read by webcam. We want the same image with marked output, that this is a part of face and this is a part of eye. So this function will take two arguments, gray image and color image. And what's next? And now we have to detect face. So for detect face, let's use variable faces. Okay, and type here face cascade, and from face cascade we are going to use detect multi-scale class. What is this? So this is our feature. Okay, so using this feature we are going to detect multi-scale. Okay, this is some parameter, this is some feature, so we are going to detect multi-scale. And from where we are going to detect, this is just showing that we are going to read. What is this? This is the feature of face. So from that image, from this image we want face. Okay, from this image we are interested in detecting face. Okay, we are interested in focusing on face. Okay, so that's why I am using here face underscore cascade dot detect multi-scale. And what I am going to pass here, I am going to pass here gray image. This is gray image. So from this gray image we are interested in getting face. Okay, so that's why I am going to use here face cascade. From this face cascade, detect multi-scale. From where? From this gray image. So if you go on documentation of dv2.cascade classifier.detect multi-scale class, and you will see that it take first argument as image, and second there are many other argument, but we are interested in only three argument. This is image. Okay, so this is image, and second argument is scaling factor. So we have to use different scaling factor. So I have already tested it on many other values, and I am getting a good result on 1.3. Okay, so this is scaling factor. And what is next? This is minimum number of neighbor. So let's take here 5. So these two are only parameters which you can change also. You can try on different parameter, but I am getting a good result on 1.3 and 5. Okay, so I am getting good result on this, that's why I have chosen this value. Okay, and this is a gray image. Okay, so this class will take 3 argument. So we got our face in this variable. Okay, so in this variable we got the coordinate of face. Okay, we don't get any face, we got the coordinate of face. We got what we got the area in that real-time image where the face is located. So this function will return the coordinate of face on that real-time image. Okay, so what we have to do next? We got our face, but next is to plot a rectangle on that area of face, so that we can detect as a output that this line is showing that it's a face. Okay, so after detection we have to mark it with something so that we show. Okay, so for that I'm going to loop over this over this coordinate, and we have to find out x-axis, y-axis, and also width and also height. Okay, so this function will return this four value x, y, w, z. Okay, so we have to loop over because it will return coordinate, so we have to loop over on this faces. Okay, and what we have to do, we have to plot a rectangle. So use here cv2 dot rectangle and pass here color image. Okay, color image, and second one is x comma y. What is this? I am going to explain you. So first of all, let's understand this using paint. Okay, so let's use this. Okay, so this is our graph. Okay, and here suppose let us consider that this is the area of face. So our function will detect that this is a part of face from that image. Okay, so this is our face, this is the area of face. Okay, and what is this? This is x and this is y. Okay, this is x and y coordinate. And what is this? This is w. This complete value is w. So this become x plus w. Okay, and what is this? This is height. Okay, so this become x plus, the coordinate is x plus w comma y plus h. Okay, so this is xy, this value is xy, and this value is x plus w comma y plus h. Okay, so these are two coordinate on which we are interested in. We are interested in only on this and these two coordinate we want. Okay, so this function is returning the same. So we are going to pass here xy, and what's next? Next is the second coordinate is x plus w comma y plus h. Okay, so these are two coordinate which we are interested in. Okay, and what's next? We have to pass. So we got our color image. We are going to plot a rectangle on this color image. As I have explained you that we are going to process this gray image and detect feature from this gray image, and after detecting the feature we are going to plot it on our original image, which is this color image. Okay, so this is first argument as color image, this cv, okay, sorry, here cv2. So this cv2 will take cv2 dot rectangle, and it will plot on a rectangle on this original image, and this is xy first coordinate, and this is second one x plus w y plus h. Okay, and what's next? We have to also give a color of that rectangle, in which color we want. So let's give here, this is 255.0.0. okay, so this is RGB representation for blue color. Okay, so let's give here, this is blue color. Okay, This is RGB representation for blue color. Okay, so I'm going to plot a blue rectangle for face. Okay, so that's why I have used this in color in RGB format. Okay, if you are interested in any other color, then you can go here and search for RGB color and you get your color. Yeah, something like, if you are interested in dark red, then you can use this 13900 or something different which you want, you can use here. Okay, you can use here. And this is done, color is identified, coordinate is done, but we also have to pass one more parameter, that is thickness of that rectangle. So let's give thickness to 2. Okay, so 2 is the thickness of rectangle. So this is done. Okay, so if I'm going to, if we return here from here this color image and do all the pre-processing and run this program, right now this program will not run because we have to add some more functionality, like we have to read the image, real-time image from webcam, and also we have to convert this in grayscale format, so that we have to extract this gray image, and we also have to extract this color image, and then we have to pass this in this function, then function will display the output. So right now we are not able to run this, but if we are going to run only on after this, if I'm going to return and if we are doing only up to this, then we will get only a blue rectangle showing face. Okay, so our face detection work is done up to here. Okay, we find face from this gray image and we plot the area of face, we cover the area of face by marking a border of rectangle. Okay, so up to face detection is done, but what next we have to do, we are also interested in detecting eye and smile. Okay, so for that, eye and smile exist inside the face. Okay, what is that? Let's understand on paint. If we have here eye, okay, so this is our eye and this is our smile. Okay, so our eye and smile is inside this region only. Okay, so it means that our region of interest, what is region of interest? So this is our region of interest, because all other things are inside this only, we are not interested in this region. We got this face region, and eye and smile also exist inside this region, so our region of interest is inside this we are going to plot something like that. Okay, so this is our region of interest. Okay, so we are going to do everything inside this loop only. So we have successfully plotted rectangle, and what's next? Let's mark here region of interest. Region of interest gray we have to use. What is this? I am going to tell you. This is region of interest, and I am going to use that gray image, and I am going to use from that gray image only y from y to h, y plus h. What is this? Let's write this, then I will tell you what is this. X plus w. What is this? So this is our complete image. Okay, this is our complete image, but we are interested only in this part. Okay, initially we got this, we got this and we got this, but now we are interested only in this part. Okay, so we are discarding everything else. Okay, so that's why I've used here gray image, do slicing and extract this range from y to y plus h. This is a part of strings list slicing. Okay, so and extract the y coordinate from y to y plus h and x coordinate from x to x plus h. Okay, so we are interested only in that facial region. Okay, similarly for Color image also our region of interest is same, but for this use here color image, and same you have to do same here. Our region of interest is only up to inside that face region, okay, that's why I have used here. So we decrease our focused, so we got this our region of interest, okay. So we got our region of interest. Now same we have to do which we have used here. So define here eyes, okay, one variable eyes, and give here eye cascade, which we have read it from this eye.xml file, okay. This is a feature, and using this feature we are going to detect multi-scale. And what we have to pass here, now we don't have to pass this gray image, because this gray image will contain complete image, okay. We are interested in detecting eye in that feature, in that face only, okay, inside that face. So now our region of interest is this one, this ROI gray is our region of interest, okay. So let's write here ROI underscore gray, okay. And same parameter you have to pass scaling factor, and let's give here scaling factor as 1.1, and second one is minimum neighbor I'm giving here 22 because I'm getting a good result on this, okay. So we got our eye coordinate also, using this. What we have to do, similarly we have to perform here, use ex for x-axis, use ey, and use and use ew, okay. So x, y, and width and height, we got it from this in eyes, okay. So we are going to loop over this, and same we are going to do here to plot it using cv2 dot rectangle. Similarly same will repeat, and what we are going to do here, we are going to plot on region of interest or color, okay. What's next, same ex and ey, this is our xy coordinate, and this is ex plus ew and ey plus eh, okay. So this is done, and what we are going to use here, I am going to use a green color. So give here red, we have green to 255 and rest to 0. So this is green, okay. What is width, width is same 2, okay. So this is a green color, and this is width of rectangle as 2, and these are the coordinate as I have done here, but this is for eye coordinate, these are eye coordinate, okay. So this is done once. Now we are not going to loop inside this, because for smile, if there is something inside eye, then we are going to loop inside this and make eye as region of interest and perform on any other thing inside this. But now smile is inside face, not inside eye, so we are going to leave this loop, okay. So let's come out from this eye loop, this is eye loop, okay. This is face loop, okay. Face, we have eye, smile, nose, everything inside face, okay. So we are looping inside face only, okay. But if there is something else which is inside, let's consider there is something inside eye, then we loop inside this and we make eye as region of interest, okay. But right now region of interest is at this face only, okay. So now let's create one variable, this smiles variable, okay. So smile, let's create one variable smile and pass same, everything is same, smile underscore cascade dot detect, same thing, no difference. And inside this our region of interest is same, ROI underscore gray, this is our region of interest, that is facial region of interest, okay. And let's pass here scaling factor as 1.7 and 25, Okay, so same, we have to loop over this sx, sy, sw, sh. Okay, in what is smiles, and same we have to do, no difference, cv2 dot rectangle, and we have to plot here same on ROI color we have to plot. This is our region of interest. Okay, this ROI color. What is the coordinate? Now the coordinate is changed, sx, sy, and this is sx plus sw, this is sy plus sh. Same like this. Okay, same. And I'm going to plot smile by using red color. Okay, so let's give here 00255. Okay, so this is red. And what is the thickness of rectangle? This same too. This is done. This function is completed. So what we have done in this function, first of all, we studied the face feature by using this face cascade, and from this face cascade we are using this face cascade dot detect multi-scale from this gray image, because CV2 will work only on gray image, and this is scaling factor, then this minimum neighbor. These are some parameter which we are going to use to tune our model, tune the accuracy of our model, and we loop over in that facial region, and we plotted a rectangle in that color image using the coordinate x, y, w, z. Okay, using this coordinate we got x, y, w, z, and we plot it on that using this feature cv2 dot rectangle, and this is color, and this is the length of thickness of that rectangle, and this is region of interest. What is this? Now we are decreasing the size, decreasing the our focus. Now as we got x, y, w, z, so now our focus is only in this region, only in this facial region. So now we got our x and y and w, z. So now our focus is only in this region, because this is a face and rest is body and something different. So we got our face and everything is inside face, so we make it as a region of interest and we do everything inside this. Okay, so that's why I've created this variable region of interest gray, which will decrease image, and which is yeah, so this will create a new image, new gray image containing only face. Okay, and this is just to study. Okay, this is not a separate image, this is just to study. Okay, and now this is region of interest, and we are going to detect eye in that facial region. Similarly, we are going to detect smile in that region of interest, in that facial region, and we plot using this cv2 dot rectangle and using this one. Okay, so we are done with this. So we are done with this, and what's next? We have to come out of loop and return here color image. Color image. Okay, this function is completed. And now what's next? I will tell you more when I will run this function. Okay, so this function is created. What's next? We have to do doing not doing, let's write here reading real-time image. Okay, so what you have to do, define one variable video. Okay, I think video is let's take here video image. Yeah, let's take video image, or you can use real-time image, any other variable which you want. cv2 dot, we have to use video capture. We are going to use this one, this feature of cv2, video capture. And what's here? You can pass here either 0 or 1. When you have to pass 0, when you have to pass 1. If you are using internal webcam in your computer, if there is inbuilt webcam, then use 0. If you are using external webcam, then use 1. Okay, if using external webcam, then use one. Okay. Okay, if you're using external webcam, then use one. If you have inbuilt webcam in your computer, then use zero. Okay, so we got our real-time image inside this video image file, inside this video image variable. Okay, we got our real-time image. What's next? We have to use one infinite loop because we are interested in running this program infinitely until we are not breaking this, we are not exiting this, because we are reading our image and we are displaying it as a result, but we are not interested in exiting the program. We are interested in infinite, so we are going to loop over infinite time. Okay, while true is showing that it's an infinite loop, and we are going to use here one variable. Let's take it as a what you can say, color image. Let's take here color image, same color. Let's take here color I or color IM. Okay, this is color image, this is same, this color image. Okay, which we are going to plot here. Yeah, or let's take here color underscore img. Okay, so this is color underscore img. So what we are going to use here, from this video image we are going to extract color image. Okay, so how we can do this? So video image dot read we have to use. So this function will read from this video image, this is not a video image, let's use here video capture. Okay, so this is video capture. So from this this variable will help you to visualize it more clearly, so that's why I am using here this variable video capture. This will capture video. Okay, this will capture video, and from that video I am going to extract video image dot read. This will extract color image. Okay, on which we are going to do some analysis. Okay, this is our color image. Okay, but one more problem is that this variable will return two argument, first argument and second argument. But first argument is not color image, first argument is something different which we are not interested in here. Okay, so second argument is this color image, so we are interested in extracting second argument. So let's use here underscore comma. Underscore comma underscore will store first argument, and this color img will store second argument. So that's why I have used here underscore comma to read second argument of this function. So color image will store the second argument of this function. Okay, so that's why we have used this. Okay, so this is done. And now what we want gray image, gray underscore img. We are interested in gray image. So we got our color image, but now we have to convert this color image in gray image also, because we need here gray image and color image both. Okay, so how we can do this? So use here cv2.cvt color, this one. Okay, so use here cv2.cvt color, and what you have to pass here, same this function to convert this in color image to gray image. So pass here color image. Okay, and what is second parameter? Second parameter is the main parameter which will help you to convert it into gray image. Okay, so what you have to do, cv2 dot color, use capital letter color underscore rgb to gray. Okay, we are interested in this one. So we are passing here first argument as color image and second argument to convert it into RGB to gray. Okay, so pass here second argument cv2 dot color underscore RGB to gray. So this complete will convert it into gray image. This will completely return a gray image. Okay, so we got our gray image, we got our color image. Okay, so we have done everything. Now what we have to do? This is our result. Let's type here result. Result is equal to detect. We have to call our detect function, and we have to pass first argument as gray img, second argument as color img. Okay, so first argument as detect image, and second, in that detect function, first argument is gray img and second argument is color img. Okay, so we got this. What's next? Okay, so we have done this. Now we have to display it as a output. So how we can do this? This is just a image, but we want a real-time image in the form of video. Okay, so for this, use cv2.imshow imshow function. Yeah, this one. And you have to pass first argument video. And what's next? Next is the result which we got from here. This is our pre-processed. This is our pre-processed result with this rectangles on that image. Okay, but we got, and after running this, we will the program will run, but we also have to exit it. So for to exit it, because it is infinite loop, so if we are interested in exiting the program, so how we can do this? So to exit this, you have to use if statement, if cv2.wait key you have to use. This is just to exit. Okay, let's write here, just to exit, just to exit. Okay, this is not anything, just to exit only. Okay, so you have to use your wait key is equal to 1. Yeah, and you have to use 0xff. This is something weird but this is only just to exit. Okay, you have to, you can pass here anything a b c d e f g h, which after pressing that key the program will exit. Okay, the program will not exit. This if statement will be true. Okay, so let's type here x. Okay, after pressing x key, or yeah, after pressing x key, this will exit. Okay, you can type any key. If you type here a, then you have to press a on the key from the keyboard, then it will and type here break, then it will exit. Okay, if you type here x, then this if statement will become true and break will be called and this program will exit. Okay, this loop will exit. Okay, so that's why I have used here. You can type any key which you want. Okay, you have to just pass the alphabet, and after pressing that key, break statement will be execute and this loop will exit. Okay, so after exiting, what you want? After exiting, I want that video capture will be closed. I want to close the video capture. Okay, I want to off my webcam. Okay, so use this video capture dot release. This will release, this will exit as from here. When it execute this one cv2 dot video capture, then our webcam will be on and it will read the image from, it will read the real-time image. Okay, so after executing this break statement, this loop will be outside from this while loop, and next statement will be executed, this video capture dot release. This will off the webcam. Okay, and what's next? I want to cv2 to destroy all windows. Okay, so this is a destroy all window, completely clean all window. Okay, destroy everything. Don't try to yeah, don't try to execute anything. Destroy all the windows, because there is new window will be created when we run this program. A new window will be created here, and after clicking this, that will display the image. Okay, that will display the output. So cv2 dot destroy all window means destroy everything. Okay, so we have made this project, and after running this, you will see that it will display output in the form of real-time image. So I am going to clean this. Okay, so let's run this and see what's happening. Video image is not defined. There's something wrong. Oh yeah, here I've used here we have to use here video capture, okay, because I've changed the variable from video image to video capture so that it you can understand it more comfortably, because this is, yeah, now it will run, okay, because we are reading from here video capture, so that's why we have to use here. Yeah, so let's save this and run. So as, okay, so we are getting a good result. So I am getting a result here, as you see that this is a blue which is showing that this is a part of face, okay, and this green is showing that it's a eye, and this smile is not detecting good because right now I am not smiling, but when I smile then the model have to predict, that model have to plot here red, but it's continuously marking here that I am smiling, but I am not right now I am not smiling, okay. So first of all I will modify that, I will adjust this parameter, this scaling factor and minimum neighbor, so that it will run, yeah, more accurate. So first of all let us understand what's going here. So how this all done, okay. What I have done here, so I have from the by using this cv2 dot rectangle, I have plotted this xy, this is xy, and this one is x plus w comma y plus h, okay, and this is showing that it's a blue and its thickness is 2, okay. So this is all. So this is now, or this is our reason of interest. We are not interested in this part, this complete part. We are only interested in this part because eye lies inside face, okay. Eye lies inside face and smile is also inside face. So we have decreases the image by marking that, point out only the region of image from y to y plus h, from y to y plus h, point out only this, and from x to x plus w, from x to x plus w, this is the width of rectangle, from x to x plus w, and this is height, so from y to y plus h, point only that part. So we have converted that gray image also in region of interest in new gray image we have created, and also we have converted it in new color image, and we are going to use this one as a our as a new gray image, okay, as a new gray image, and we have done everything and we have plotted everything inside this, okay. If we are interested in somewhere reason outside this, so we break this loop and go outside, okay. So that's why we have chosen here region of interest this, okay, and our eye is this, okay, but smile is outside that eye because smile doesn't lie inside this eye. So we have break this loop and we have gone outside from this loop, and we define one variable smile and plotted everything, but the region of interest is same, okay. So here I, okay, so everything is fine, yeah, so everything is fine, but I'm not getting a good result for smile. Eye and face is clear, yeah, it's detecting correctly face and eye, but it's continuously showing and this smile, but right now I am not smiling, so we have to adjust this one also, okay. So let's do this. So first of all let's exit this. So for exiting this, if you are going to use this one, then this will not exit. Why? Because loop is running infinite, okay. When you exit this program it will execute once again, okay, because loop is executing infinite. So to exit this we have to make true this if statement. So to make true this if statement, type here x, okay. So the now the program is exited, okay. So we have to adjust this one. So let's take here 1.9 as scaling factor, and let's take here 27. I think now this will run good. Let's run this. Yeah, so I am now getting a good result. Yeah, now it's great, it's fine. Yeah, correct. So when I'm neutral, yeah, no, no red mark. Yeah, I think I have to change it to 26. Yeah, it's now it's showing correct. I think we I have to show the teeth. Yeah, then yeah, it's showing. Yeah, it's fine. You can adjust this by adjusting this scaling factor and minimum neighbor. You can adjust that and you can make it more accurate. Yeah, it's better than previous one. Yeah, now I'm not getting. Yeah, but when I smile, then I'm getting red mark. Now I'm not getting. Okay, that's fine. Okay, so it's running. Correct. When I'm showing my teeth, then I think, yeah, it's running fine. Okay, so everything's done. So let's summarize this again. Once again, I'm going to explain you what I have done here. Uh, First of all, I have imported this library and the, store this face cascade and eye cascade and store the feature by reading this XML file and then try to detect the feature from this gray image. Okay, using this cascade value, using this cascade feature, I have tried to detect from this gray image, and by adjust scaling factor and minimum neighbor, I got this face. Okay, the coordinate of this face, and then I loop over this faces and plot the and plot the rectangle in that color image. Okay, I have extracted the feature from this gray image and plotted in that color image because I want the result in color image soon. Okay, so that's why I have done this, and this is just the value of rectangle showing that it's a color blue and it's have thickness 2. Okay, and now this is our region of interest and we are interested inside that facial region, so it's showing this one. And so we have stored this gray region of interest and this is color region of interest. Now this is our new region of interest and we have done everything inside this region of interest. So we study the feature of eye inside that region of interest gray, and using this value we got eye, and we loop over that eye to plot rectangle inside outside that eye to show that it's a eye. Okay, then we have extracted smile feature from that region of interest which is face. Okay, from that we have come out from this eye loop, and but we are still inside this face loop. Okay, so we have detected smile from this facial region of interest, and we have plotted the rectangle also for that smile. Okay, a red rectangle with thickness 2. Okay, so these are just the coordinates. This is sxxy. Let's run this and show you what is this also, so that everything is clear. I want you guys that all the concepts are clear. Okay, why this is going on. So this is sx, this is sx. Okay, let's see this mark. Okay, so this is sx, and what is this sx plus sw? This is sx plus sw, and sy plus sh, this is sy plus sh. So we are interested only in this and this coordinate because okay, so to plot a rectangle we need only two coordinate. We plot one parallel line, we plot one parallel from here, one parallel from here, and every rectangle will be plotted. Okay, so we are interested only in two coordinate, and this is just to show that it's a red color, and this 2 is showing that it's a thickness of 2. Okay, hope it's clear. Okay, so we have returned this color image, and from this we are going to read the image from webcam and stored in video capture variable, and we are going to execute it infinite times because we want a real-time image and video in the form of video, and video is not exited. We want that video is exited when we want. Okay, so that's why we have used here while true, and this video capture dot read will return two values, but we are interested in only in second value. Okay, so second parameter, to extract the second parameter, I'm going to use here this underscore comma color img to extract second parameter of this function inside this color img variable. Okay, and to convert this color to gray, I am using here cv2.cvt color, and first argument as color image, second argument as cv2 dot underscore rgb to gray. Okay, this will convert it in from color image to gray image, and we store it inside this gray img. Okay, then call that detect function and pass this first argument as gray image, and second one is color image, and store this color image, this resultant image, in this one. Okay, in this result variable which is returned by this function. Okay, what's next? And then call cv2.imshow. This code is just to show that result in the form of video which we got from this function, detect function. Okay, and this part of code is just to exit the loop or program. Okay, and this is to off webcam, and this is to off this. What is this? Let me show that. So this is a window, is created. Okay, so to off this window, I am going to use your cv2 dot destroy all window. Okay, yeah, it's showing when, I think when teeth will be visible, then it will detect that smiling. Okay, when my teeth is visible, yeah, no, not teeth, I think when it's spread something. Yeah, when it's spread, because smile will sometimes spread this. Yeah, it's study something, some calculation is done, some mathematical calculation. You can see in that it's a very weird XML file. So that XML file and CV2 library completely both are cascade feature of CV2 and that okay. Yeah, so it's doing some calculation and showing that the result. Yeah, when I go far, then it's you can also make it more accurate when you will use TensorFlow. Okay, if you're going to use TensorFlow, then you can make it more accurate. This model will be more accurate, and this will display good result. Okay, right now this is showing it's great, but if you're going to use deep learning and TensorFlow, then you will get a more beautiful result. But here there is some error, sometimes it's not showing, like, I mean, yeah, you can also modify it, you can also tune this model by just writing this from here, by adjusting the scaling factor and this minimum neighbor. But right now it's fine, it's working. Yeah, it's working, it's showing a good result, not bad. But as compared to TensorFlow, you can use the TensorFlow and PyTorch to make it more good, and but that needs some effort to do that. Yeah, OpenCV is very easy to understand and build, but TensorFlow has more accuracy as compared to CV2. So that's fine. So we have successfully built this model. Okay, face eye smile detection system, in which we can determine face, eye, and smile also within just a 35 line of code. Okay, so I hope you guys enjoy this video, and you have learned a lot of things. Okay, if you have any doubt regarding this or any other stuff, then you can post in the comment box. I will try to resolve your issue. And if you guys are interested in some other videos, then try to post me. I will try to make some projects on that also. Okay, so Hope you guys enjoyed this video, and thank you guys. Thanks a lot for watching this video.